I'm here today to talk about the real-time web. Needless to say, I've prepared a few slides. This is a pretty basic slide. It's a goat slide. It's a winning sports slide. It's the money slide. My name's Aaron. I've been building websites since MySpace was cool. My band on tour needed custom profiles, and you could just inject JavaScript and CSS directly into their platform. We ended up making money selling it to other bands on tour, and that kind of inspired me to learn it, master the craft. So eventually I moved to Colorado to help two friends grow a company to north of $1 million in revenue. They sold it, and I started freelancing out of Galvanize in Denver, in their first location in the Golden Triangle. Did some consultancy for a while, building Ruby and Node apps. I work in open source. Is anybody familiar with SUSE, the grid framework for SaaS? I play with that a lot and help develop it. And now I'm in education at Galvanize, where I instruct at our Boulder location. But before we get into Ruby today, we need to start in the browser ecosystem. And from the outside observer, it looks a lot like this. There's chaos. Every time you peek in, there's like something new to see. Patrick has no idea what's going on. It's just cats everywhere, an absolute mess. And, you know, JavaScript got off to a bad start, right? Granted, it was developed in 11 days, so it's a pretty impressive feat considering it's so ubiquitous in our ecosystem today. Meanwhile, it's improving. ECMAScript 6 shipped. We've been talking about it for a while, and it's here. But JavaScript still has a problem. I know we've all felt that pain. And a lot of people see that and feel frustrated by it. I think it's actually an inherent feature of the web. Because the reality is none of us chose JavaScript. Unlike Ruby, we chose the browser. Our users chose the browser. And as a consequence, we have a lot of different perspectives, a lot of different ways to solve problems being brought to the exact same language and the exact same platform. And as a consequence, we have this massive diversity of solutions. And through iterations, we've seen new and innovative ways to solve problems and new and innovative ways to keep up with users' expectations, which I want to spend a little bit of time talking about. If you haven't read the Tao of Web Design, I highly recommend it. To me, it boils down to the one sentiment at the bottom, that new technology initially inherits constraints of its predecessor. And we've seen this in every platform humans have ever invented to share media. With print, for the first time, we were liberated from the constraints of time. We could communicate to people much farther in the future than we ever could before. And with the radio, we could reach people who were otherwise disengaged, the blind, or those otherwise engaged with their eyes and occupied driving. The TV came around, and we were able to add this like visual context to the medium. But in each of these cases, we've seen them inherit constraints of the predecessor. It was especially obvious with television, which for some time was called radio with pictures. And they would sit there and just chat. They would treat the audience as though they actually couldn't see the things that you'd hear them describing, very obvious attributes of the people they're having conversations with. With the internet, like all other mediums, we've been liberated from something. We've been liberated from the middleman, that we can suddenly publish and absolutely anybody can participate. But we're still inheriting so much, both from television and radio, but especially print. The page metaphor for some time now has been said to be killing the web. We're not working with pages, we're working with systems of components mapped to routes. We're not designing stuff above the fold, which is inherited from marketing, where everyone cared what article was published on the top half of a newspaper because that's what people would see. And this really strange language still defines how we work in the web, but it's broken. And that was never more obvious than when the iPhone was invented. Very suddenly, we had to adapt our views to different resolutions, different contexts. it's never been more true than since we've started to develop thick clients on top of our APIs. I think that apps of today are responsive, reactive, and real-time, according to both the technology we now have to build it, but also the user's expectations of how certain types of apps are expected to behave. I'm going to go over each of these 3 points, starting with responsive. You may be familiar with the big 3 points to responsive design. There's fluid layouts, which is using percentage-based width so that it can adapt to any resolution. Flexible media, which enables you to determine the density or weight of an image based on resolution. And media queries, which gives you the ability to kind of control both of those things based on resolution. And that is great. Ethan Marcotte really changed things for us with that formula. But one thing that we're not taking full advantage of, which I think is the 4th component of responsive design, is context. Resolution alone doesn't tell us enough. I imagine a scenario where you can detect in your application the current velocity of a user. The fact that they're away from where they've told you their home geocoordinates exists. I don't know what that means for you, but we have that information in the browser. And a number of other things besides resolution that we can start to take advantage of, not later, but now. And then there's reactivity. Reactivity is a really fun concept, and I think that the best example we have for it is a Google spreadsheet. The definition might be reactivity is when a view re-renders when the underlying data changes. This isn't a very new concept. When you have a spreadsheet where cell A equals B plus C, and C changes, so does the value of A, because it's a part of that formula. We see it in character counts on Twitter as it counts down as you approach 144 characters. In spell check with the browser, when the underlying data changes, when you go from a properly typed word to a typo, you get a red underline. We can consider that too reactivity. And with reactivity comes reactive latency compensation. This is a form of enhancement for the user that makes your app feel incredibly fast. And the idea is that the network's very, very latent. It takes an unknown amount of time for a transaction to happen. So the best way to approach this, given the tools we have, is to post first any user data to an in-memory representation of your database. We have hundreds of implementations of this now. And then, because the views are bound to that in-memory representation of the data, they can re-render immediately. And as a consequence, it's optimistic. It assumes the user gave you what you need and expected it to before it posts over the network to the database. You then obviously validate and respond with errors appropriately, which should take the normal amount of time. But done well, in the golden path, your user flies through their applications. With larger and larger JavaScript clients built on top of APIs, or Rails APIs maybe, we've started talking about performance and page speed. And there's a couple of metrics people tend to look at, which is the page load time. How long does it take just for the whole thing to be done? And that's fine. We should definitely consider it. We started talking later about time to first paint, and Amazon really led this initiative by showing numbers where if they could just get anything on the screen, whether it's styled or unstyled HTML, as quickly as possible, by reducing that wait time by milliseconds, they increased conversions by some number, and that's really fascinating. We also talk about this above the fold paint, which I just think is incredibly silly. I think the thing we need to think about more and more is time to operate, which I describe as the time it takes for a user to make a decision about what they'll do next in your application according to their own agenda. So the time it takes for a user to decide what they'll do next. And we have to stop doing this. It's a blocking interface. The time to paint is extremely high. But if this couldn't possibly increase conversions, I have no idea what I'll do next. I'm just going to be surprised by it. Facebook does it really well. If you hit stop before their entire page loads, what you get is a UI preview. placeholders that represent the general shape of the data. I know looking at it, there's probably some advertisement I could ignore on the right, that my friend's feed will be in the center. You can, different screen maybe make out that there's a placeholder even for their profile photo. But immediately I can contribute. Like, that's done. There's not much to render there. And they get it out quickly. And it's non-blocking. Like, no matter what I want to do, I know where I'm going next. Within reactivity, there's also this concept of reactive online, offline state. The users want to know that their data is up to date, that it's safe. Who uses Slack? Awesome. Slack does this really well. If you go offline while using their platform, immediately it's obvious that something's not right. It gives you a red X, the input field goes yellow. A little drop-down indicates that it's going to try to reconnect in some time, and when that fails, it'll post your text where it's eventually going, but it's muted, and there's a small note that asks if you'd like to resend. You can click that, and it tries again, this time with a longer wait period, counting down, keeping you informed, letting you know that while we're taking care of things, your data's not safe. Your data's not up to date. Like, if you're putting in, an important message to your boss, you need to wait before you get on the plane. That's very important to most users. And it goes through after reconnecting to the network. I love Twitter in all they do. They haven't thought through this scenario. When you're offline and post a tweet, you get internal server error, which can't be true because you're not online. So there's a lot to think of there, but I think even more to think about and consider with reactivity built on top of a real-time system. When we say real-time, what we mean typically is data on the wire. That is to say, you have a portion of your view or an entire application on the client intelligent enough to re-render different views at different routes as underlying data changes, so it's reactive, or as the user navigates the interface. And in both of those scenarios, we have tons of tools built around it to enable it, but the key concept here is data on the wire. You're not transmitting HTML when they submit a form. You're only transmitting the data, and you're never doing full page refreshes. And consequently, everything's always up to date. The real-time web has made our social apps more social, our utilities more useful, our collaborative tools more collaborative. Google Docs comes to mind. And I don't know about you, but the first day that I noticed in Gmail I no longer had to refresh, or the first time I noticed typing into Google's search as results just came in under my feet, I was thrilled. The utility of speed is always a competitive advantage in nearly every business it's been applied to. But there's unique constraints. There's unique challenges when designing them. The archetype example of real-time applications is a chat app, and I'm going to show you a chat app in Rails 5 later, but the list view comes to mind. Slack, obviously, being a chat platform, appends new data to the bottom. But you need to consider then what happens when it overflows. Do you scroll the viewport? Do you leave that up to the user? What happens if they've scrolled to the top of it, reading older messages in their history? So there's unique algorithms and problems to solve in that space. Twitter does the opposite. It prepends all of its incoming data. And the way they chose to solve this is really clever, because if you're scrolling down to previous tweets, it would interrupt you as new stuff came in if they rendered it right away. So instead, they batch it and appear to store it in memory in the client, and on click, enable the user to dictate when that rendering happens. We also can consider progress retention in real-time apps. This comes to mind when I consider emergency situations. Eric Meyer, the inventor of CSS, has been talking a lot about designing for crisis. And progress retention could really help a lot there, whereby a user filling out a request for emergency supplies in the next boulder flood doesn't need to hit submit. It should be there to make them feel good about submitting the form at the end and certain that their data was posted. But in situations like that, we can retain the data in real time. Google Drive does this, and they keep the user informed. Notice at the top right, it says saving. I just typed in ASDF, and when I'm done, it goes away. I know my data's up to date, it's been retained, and it's safe. Airbnb does this quite well. With the exception of when you scroll down, that green saved message only flashes for a few minutes, and it's mostly out of the viewport when you're interacting with their site. They also don't have a submit button, which personally challenges me because I don't feel as though it's saved, especially if I don't see that indication. Combating all of this is the Realtime web. You probably subscribe to certain newsletters or get spam you don't want, and that stuff comes in real time and it's a distraction. So services are built around that to prevent it. So I think it's important, this one in particular batches all of the things you're subscribed to and sends them to you just once a day. So through all of this, I think it's important to consider, while the technologies are getting us closer to making a real-time default for many different types of applications, not just the chat apps that you'd expect, I do think we should keep in mind that it's not always necessary. So apps of today, to recap, are responsive, as they have been, but with context. Reactive, and all of that implies and real time in many cases. We can use all of this today. I've been working in Meteor for some time now. There's a lot of people shipping it to production, and Rails is coming around. In Rails 5, we have action cable. Volt has existed for some time now, which uses Opal to transpile Ruby into JavaScript. Rails has a unique approach to it, which we can explore now. There's a couple components to it, actually. First, it uses Redis as sort of a middleman in the system. Specifically, its pub-sub feature, and WebSockets. When you consider real-time apps, there's sort of three major competing approaches to it: long polling, short polling, and WebSockets. WebSockets is definitely winning out in many ways, so Rails has rightfully adapted that into its ecosystem. They have special terminology for it. A cable, as you see in action cable, dictates or determines that there's one socket per session. So on any app, you can have many sessions, and a socket is made for each of them. And within that, you have different channels, which you can think of as any resources that are real-time. So in the chat app that we're going to look at, built with Rails 5, uses a messages resource or a messages channel. And then there's the broadcaster, which is responsible for emitting events to anyone subscribed to specific channels on the socket. So let's check it out. I don't know how to mirror them, so I'm going to kind of like turn around and look at the TV. Does this work? Thank you. Yeah, that'd be awesome. Yeah. So we can see on the left here, make both of these bigger. I'm going to go to the index route on the right, which is using incognito mode to use a completely unique session. And here I'll log in as Joe. And here I will go to the root of the app to log in as myself. And I'm going to use the form to post to the server which will use Ajax. I'll show you where that's defined momentarily, and it should emit via the broadcaster to both cables and consequently re-render the view. So first test, hi there. This screen is huge. All right. What's that? Oh, cool. I am going to post one back. Cool, so we can see they're communicating, and very briefly, I will dive into some of the code. The things to note are the gem file is just including action cable. You could use this in Rails 5 by going to Rails/action cable-examples. Instead, we're using Rails 4.2 here, along with the action cable gem. The routes look exactly as you expect the routes to look, so I'm not going to check those out. The controller should also look familiar. Let's dive into that real quick. Here we go. We've just defined create here and reference the action cable server and invoke the broadcast method, which as a string determines in its first argument which resource, which channel it should broadcast to, along with the actual data. That's it. From there, the channel configuration takes over, in which there's a little bit more than you want to deal with right now. If you note, yeah. There we go. Cool. What ends up happening behind the scenes is it posts to Redis, which acts as a middleman, and then delays a job to write to your normal server via active record. So you have a really highly performant middleman sitting there where you point a socket that's listening and broadcast to each channel as needed. I'm going to cut there. I wanted to show more code, but I am going over time. So thanks.